All right, let's do one more along these lines. We've got f of x is equal to negative 5 times the cosine of 3x. For the amplitude, remember we said the amplitude is the absolute value of whatever a is in front of it. So our amplitude is actually the number 5. However, that negative 5 is going to affect the way the graph goes because that negative is going to cause a reflection of what the original cosine graph would look like. But for our purposes, we're going to go with an amplitude of 5. The period, that's going to take a little bit of work. The period of this function is going to be found by taking 2 pi and dividing it by whatever is in front of x. In this case, it's going to be divided by 3. By the way, we always treat b as though it's a positive number right here. The period is going to be 2 pi over 3. There's really not much else I can do to reduce this. But I am going to need some key points along my x-axis in order to help me map these points. So my key points have to be at 1/4 of the period apart. So at 1/4 times 2 pi over 3. So let's reduce that down. That would be 2 pi over 12, but that's going to reduce down to pi over 6. So each of my key points are going to be pi over 6 apart from one another. So that's where I'm going to start. For my x values, I'm going to start at 0, and I'm going to add my increment of pi over 6. Now, if it helps you, here's a really good way of looking at it. We've got 1 pi over 6 right here. We're going to end up with 5 key points. Now, if I don't reduce any of my fractions, here's what's going to happen. In unreduced format, I'm going to get 2 pi over 6 as my next key point. I'm going to get 3 pi over 6 as my next key point after that. And then I'm going to get 4 pi over 6 as my next key point after that. And all of that is just adding pi over 6 each time. But I don't want to use these non-reduced fractions, so I'm going to reduce them, and I'm going to have key points at pi over 3. 3 pi over 6, which reduces to pi over 2. And 4 pi over 6, which reduces to 2 pi over 3, and that's one full period of our function. For the y values, normally the y values for a cosine graph go 1, 0, -1, 0, and 1. But since we're multiplying everything by -5, we're going to go like this. 1 times -5, well, that's -5. 0 times -5 is still 0, but -1 times -5 is +5 this time. At pi over 2, instead of having 0, we're going to have 0 times pi over 2. Well, that's still 0. And then we're going to be back up to -5 this time. So let's plot these on our x and y axes. So having labeled all of those points right here, starting at 0, we're going to say 0, we're going to be at -5. Pi over 6 goes to 0. Pi over 3 goes to +5 at pi over 2. 0 again. 2 pi over 3, we're down to -5, and the cycle would start all over again. So here's one cycle of -5 times the cosine of 3x. And we'll notice one more thing. The period in this case, 2 pi over 3, which we found by taking 2 pi and dividing it by b, 2 pi over 3. Our domain is still all real numbers. And even though we've multiplied by a negative, our range is going to be a closed set along the y-axis of -5 to +5 based on our amplitude of our function of 5. Well, that's the graph we wanted, and so we're done.